Algebra 1 lesson 61, we are simplifying radical expressions. So being able to take what we know with both numeric and algebraic expressions and simplify them. So when we look at this, we have a property of radicals. We're going to be using this product property of radicals by saying as long as the variables or numbers are non-negative real numbers, we can say that the square root of a times the square root of b is the square root of ab multiplying, and the square root of ab is equal to the square root of a times the square root of b. So we can split up our numbers or multiply them together to make simplifying easier. So trying a couple of these, let's say we have the square root of 225. Well, we could split up the square root of 225 into the square root of 9 times 25, or the square root of 9 times the square root of 25, which makes it a little bit easier to see that the square root of 9 is 3, the square root of 25 is 5. And when we multiply them, we say that the square root of 225 is 15. So if we were to do this with the square root of 196, we could say, well, I could split that into, let's see if I can get my pen working, the square root of 4 times the square root of 49. That would give me the square root of 196, which means the square root of 4 is 2 times the square root of 49 is 7, so that would be 14. So we can split our radicals into some of their perfect squares. So like with the square root of 72, I'll show it a couple different ways. So the square root of 72, we could say that's the square root of 9 times 8, which is the square root of 9 times 4 times 2, which we could do the square root of 9 times the square root of 4 times the square root of 2. We can simplify everything we can so that we end up with 6 root 2. Now we could have done this another way by saying the square root of 72 is actually the same as the square root of 36 times the square root of 2, which is 6 times root 2. Now we could go even further actually by saying the square root of 72, well 72, I'll break it up into its primes by saying that's 2 times 36, 6 and 6, which is 2 and 3, and 2 and 3. So the square root of 72 is really the square root of 2 times 2 times 2 times 3 times 3. And with simplifying radicals, if we see 2 of the same number inside the radicals, I can take those 2 and simplify them to just 1 outside. So I have two pairs of 2, or a pair of 2s, a pair of 3s that I can circle and pop. And if there's 2 inside, well, that means there's just 1 outside. So 2 times 3 times root 2, which is 6 root 2. So similarly, we can do any of these methods with the square root of 320. And I can say the square root of 320, well, let's see, I can break that up into 16 times 20, or the square root of 16 times 4 times 5, which means that we get the square root of 16 times the square root of 4 times the square root of 5. So 4 times 2 times root 5 is 8 root 5. Okay, so this is a method to simplifying our radicals. How about this one, the square root of 180? Now this is put into its prime factorization, so we can see the square root of 2 times 2 times 3 times 3 times 5. We can use that method of circling and popping. So if there's a pair of a number inside, we can pop them out and say that we have 2 times 3 times root 5, or 6 root 5. Let's try it with 90. And I'm going to say the square root of 90 is the same as, well, 90 into its prime factorization, we have 9 and 10, 2 and 5, 3 and 3. So we have the square root of 2 times 3 times 3 times 5. And there's a pair of 3's, and so I'll say it's 3 times square root of 2 times 5. Well, 2 times 5 can't be simplified anymore, so we can just say this is 3 root 10. Okay? Now, simplifying with some powers of 10, we're going to go back to what we know about how a radical can also be expressed as a fractional exponent. All right, so when we do this, there's lots of ways to do it. Of course, you could put it in its prime factorization. You can circle and pop. But let's say we have this top one here, the square root of 10 to the 4th. Well, Our square root symbol, our radical symbol, that's really just an exponent of 1/2. So really what I have here is 10 to the 4th to the 1/2 power, or 10 to the 4/2. All right, we've done this in a previous lesson by saying when we put them in fractional exponents, let's say we have the cube root of x squared, we could say this is x to the 2/3. The 2 always comes from the exponent on the x inside of the radical, and 3 comes from the index of the square root, or the cube root in this case. So when we simplify 10 to the 4th to the 1/2 power, really we are saying we have 10 squared, or 100. So we could do it for some of these other ones as well. We could say, well, this is the square root of 10 to the 5th. So I could actually do that as square root of 10 to the 4th times the square root of 10. And we already know that the square root of 10 to the 4th is 10 to the 4 divided by 2, or 10 squared, 100 times the square root of 10. This 1 billion is the square root of 10 to the 9th. Well, that also doesn't divide easily by 2, so we could say the square root of 10 to the 8th times the square root of 10, which means 10 to the 8th, that's 8 divided by 2, so we have 10 to the 4th times the square root of 10, or 10,000, or sorry, 10,000 times 10, the square root of 10. And this last one, this one actually works out pretty easily because we get 10 to the 6th, which is 10 to the 6 divided by 2, or 10 cubed, so we get 1,000. So remember that radicals are also fractional exponents. Now, when we do simplifying variables with having our radicals actually have variables underneath, we're going to need to split this into its different parts. And it's easiest to split it into the numbers and then the different variables. So, for instance, we can split this into the square root of 81 times the square root of x to the 4th times the square root of y cubed. And we can do each of these parts by saying the square root of 81, well, that's 9. And the square root of x to the 4th, many different ways to see it. I'll put it over here. You could see it as x times x times x times x, and you circle and pop 2 pairs of x's to get x squared. Or you can see it as x to the 4th divided by 2. So we have x squared. And then the y to the 3rd, you can see it as y times y times y. Circle those 2 y's and pop them so that we get 1 y outside, but we're left with 1 y in the radical. Or you can see it as y, you could split it into the square root of y squared times the square root of y and simplify it that way. But regardless, you end up getting 9x squared y times the square root of 9y. For the next one, we can split it up. And the square root of 162 is not a perfect square, and so we're going to have to break it up. But this one works out pretty well. We end up seeing that we can get the square root of 81 times the square root of 2, and then we simplify our r's and our s's. Well, that's r to the 4 divided by 2, and s to the 8 divided by 2, so we get r squared and s to the 4th. And we have 9 root 2. So we would write this as 9r squared s to the 4th times the square root of 2. We always want to put our radicals last so that nothing else gets confused as possibly part of the radical. Let's try the other two. The square root of 96 g to the 3rd f to the 6th. Well, we can split that into the square root of 96 times the square root of g cubed times the square root of f to the 6th. Well, the square root of 96, that's like, let's see, 16 times 5, I think. Let me make sure that no, not 16 times 5. Well, let's split it up like this. Let's do the full thing and do 96, and we do 2 and 48, 2 and 24. This is going to be 6 and 4. So we go 2 and 3 and 2 and 2. We have all of those to say we get a bunch of 2's. 2 times 2 times 2 times 2 times 2 times 3. And that should give us our 96. Let me just check it. And we do. All right, which means we can circle and pop a couple different pairs of 2's to get 4 on the outside times the square root of 6. And then with our variables, g to the third, well, I can circle 2 g's and pop them out. So I have 1g times the square root of g. And then my the square root of f to the 6, well, that's f to the 6 divided by 3, so f cubed. Putting them in order, we get 4g f to the third times the square root of 6g. And then the last one, the square root of 54. Well, we can split this into the square root of 9 times the square root of 6 times the square root of p to the 7th and the square root of q to the third. Well, that's 3 times root 6 times, let's see, I can get 3 pairs of p's out, so I can get p to the third. And we have a q popped out. And what we have left in the radicals is 6pq. All right. And last one. So Neural Helper has a square bedroom. The area measures 48 square meters. Find the length of one side of her room by simplifying the square root of 48 meters squared. So we do this by splitting it up into 2 and 24, 6 and 4. So we have 2 and 3, 2 and 2. Which means we can say this is the square root of 2 times 2 times 2 times 2 times 3. We can circle and pop 2 pairs to get 4 root 3 meters. And for the second one, the side length for a square room that's 72 square meters. Well, that's like having the square root of 36 times the square root of 2. So we get 6 root 2 meters. Well, I hope this is helpful for your homework and for studying.